Reality, my diamonds that cold. Versace trunks, I hit my backstroke. Knock on the door, she at the back, bro.
Welcome back to Houdini's Hip. So in the last part, we looked at Pyro, and we looked at how to render our Pyro simulations. In the parts before that, we looked at RBD, and we're now getting an understanding of all of the different simulation networks. We've looked at PopNets, we've looked at Vellum, we've looked at RBD, we've looked at Pyro. So now we can start mixing them together. And in destruction, you often mix Pyro, RBD, and Pop networks. You'll have perhaps a building being destroyed or a structure being destroyed, and you'll have either smoke or fire or both, and you'll have embers or debris particles, things like that. So in this part, we're going to be looking at a very simple destruction scene. We're going to be looking at slightly more advanced RBD topics, and we're also going to be looking at how to take that and then drive a debris simulation, and then take that debris simulation, which is a particle network, and use that to actually run a volume simulation. And so, yeah, we'll just go straight into the tutorial in Houdini. Let's get started.
Right, to start off with this tutorial, we're going to go ahead and actually download some assets. So I'd like you to go to polyhaven.com. Polyhaven.com, they just have a public 3D asset library. So they have textures, they have 3D models, and they also have HDRIs. So we're going to go over to the assets over here, and you can just search in here for cat. And the model that we want is this concrete cat statue. So we're just going to go ahead and download that. By default, yours might be .blend. Go to FBX rather and download that. We want the FBX file. Once we have that, we can go ahead and also look for a texture. So let's go back over to this page over here, switch to textures, and let's look for something that's concrete. This is going to be for the inside of the model, because if we are going to be taking that cat 3D model and destroying it using RBD, then the interior faces won't have textures, right? If we think about a 3D model, it's just a hollow 3D model, and the outside has a texture. But if we were to add inside faces, we need to have something that can sort of procedurally generate the inside textures for us. So we're going to have to choose something maybe like this rough concrete. So if you just type concrete, we're going to grab this rough concrete over here. 4K is fine. We're going to go ahead and download it as a .zip. And you can see here, when you do that, it asks you what you would like. We don't need blend, we don't need GLTF, we don't need either of the ambient occlusion textures over there. We will keep displacement, and we won't use normal DX, we'll just use GL, and we'll keep the roughness, right? So that's what we want. Go ahead and click download, and 4K is fine for this. So once those two have been downloaded, go ahead and extract them. And once you've extracted them, we can go ahead and jump straight into Houdini. Right, so in Houdini, first thing that we're going to do is just a geometry node. Inside of this geometry node, we're going to be creating our RBD destruction stuff. So just call this RBD destruction. And inside of here, we're just going to use an FBX character import. Now, we haven't used this one before, but this just fetches a character. If it has a skeleton, it'll fetch that as well. And if it has animation, you can bring that in with it. So we're just going to go ahead and choose our cat model. So go ahead and open up the concrete cat statue. Bring in this FBX over here. That should bring it in, and you will see textures, but just ignore that for now, because those textures aren't actually what we're going to be using. If you middle mouse on this, you will see that it is a packed geo, so it won't have anything like UVs or anything like that. So what we need to do is just unpack it. So we use an unpack, first input into the unpack. Now, if you take a look at this, you'll see that we have a bunch of attributes. We have normals and we have UVs. Those are the only two important ones that we really want. So we can use an attribute delete node to delete everything except those two vertex attributes. So an asterisk over there, and over there. So we're just keeping our vertex attributes. So if you take a look at this, we just have P, normal, and UV. So UVs are the things that are going to allow us to reapply our textures. If you're unfamiliar with UVs, it's just a way of unwrapping a 3D object into 2D space. And then we can apply a texture to that 2D space, and then once again wrap it up over our 3D model. So if you want to see what your UVs look like, press 5 on your numpad, and that'll bring up your UV viewport. If you're curious about what the texture looks like overlaid over this, you can press D. And over here, under background, you can go over to UV. And over here, it has this UV grid.pick. You can very easily choose the actual texture for the cat, so concrete cat. And in here, there's the textures folder. And we're going to grab the diffuse color, right? Once you do that, you'll see that we have what looks like a mess. So if we press W for wireframe mode, you can see that in there we have our texture. Everything that falls outside of it isn't important. We're only really focused on what is unwrapped, right? These sections over here are representing pieces of our geometry that have been unwrapped to 2D space. So those are the only things where you'll see a texture. So you could even take this into Photoshop and you could draw something in this island over here, like you could write something on it and re-export the texture, and then it'll show up on your 3D model in that position, right? So that's how your UVs work. So once again, W for wireframe, we can switch back, and then 1 on your numpad to go back to perspective view. So with this cat over here, it would be nice to have it slightly bigger. It's a very small model at the moment, so we can just transform it up. We'll go 2.5 times. Having it slightly bigger will make our RBD material fracture work a lot better. Let's go ahead and use the RBD material fracture node. Okay, we can also use an exploded view for this. So grab an exploded view, that's going to be RBD exploded view. And if you take a look at that, you can see that it splits this up into these pieces. Now, one thing to note is that the interior faces generate random UVs, basically. They're not very good, and you can see that they're very distorted. That's not going to be great for when you want to apply a texture to the inside of our faces. So we're going to need to make some changes to that a bit later on. But for now, let's just focus on actually breaking this up in a way that looks good. So I'm going to go ahead and increase the scatter over here on our RBD material fracture. We're going to increase both the primary and secondary fracture. Now, an interesting thing that you can do, but I usually don't show it too early on because people might forget about it, is this in the bottom right, where we have this auto update. You can switch it to manual, and this will make sure that Houdini doesn't reevaluate every time you make a change, right? So if I change this from 5 to 20, you'll see that nothing changes. And if I go over to the second fracture, I can do the same thing, right? Set it to 20, and everything's the same. And you'll see that it now says update mode is manual, view may be out of date. So you can now click on this refresh over here, and now it refreshes, right? So this is useful for when you're changing lots of settings at once, and you don't want it to recalculate each time you make a change, because if that happens, it tends to slow you down a lot, right? You kind of have an idea of what you want to be doing, but if you constantly have to be waiting for this to recalculate, then it's going to waste a lot of time. So it's better to switch this to manual sometimes, and then just manually refresh this. Now again, you can just switch it to auto, that's not a problem. Let's go over to detail over here, and we're going to decrease the detail size, right? Because this cat is quite small, so it needs to have very small details. So we're going to decrease the detail size over here to 0.05, so that's going to be 1/10 of the scale. We're going to enable edge detail, and over here we have noise height and noise element size. Now, a noise height of 0.1 is going to displace things 0.1 units. And if we look at 0.1 units over here on our grid, that's going to be a pretty huge gap, right? So we actually just want maybe 1/10 of this, 0.01, and element size can also be 0.2. Once again, manually update this, and we now have some interior detail. We can make further changes to this, so I'm going to go over here to interior detail. The noise amplitude, once again, we're going to want to decrease this. This is a bit high for our scale, so we're going to do 0.05, and then increase the frequency to something like 10. Once again, having this on manual is really useful for preventing this from updating as we're working with it, which can be really annoying. So just go back and refresh this. Okay, so now you may be thinking that these are very small pieces, right? If this cat breaks up into these pieces, then it's just going to look not very good, right? These look very uniformly split, and really you don't want it breaking into such small pieces. So what we're going to do is something that I haven't shown you yet, and that is clustering. So we're going to cluster sections together and have them act as single pieces, right? So it's almost like we're rejoining some pieces back together. To do that, we're going to go before our RBD exploded view, and we're going to use a cluster RBD cluster, like that. Plug it in over here. And remember, things aren't going to update the way that they usually do because we're using the manual update. So let's just go ahead and update it manually, and that's what we end up with, right? I'm just going to switch this back to auto so that I can show you what happens as we make changes. So this random detach ratio over here detaches pieces from the clusters that we generate. So you can see that some pieces aren't part of any of the main clusters. And if we decrease this to 0, so random detach to 0, then we only have the main clusters. So a good thing to do is to disable random detach, work on this, find which sort of clustering looks good for your model, and then enable random detach. So let's go ahead and decrease the size of this. We want smaller sections, something like 0.3, right? So now we're ending up with smaller clusters, and this feels a lot better. So you can see that that chunk over there would break off separately to this chunk over here, and we end up with really nice edge detail because we're now clustering pieces together. So we generate all of that really great detail with our RBD material fracture, and then use the cluster to stick those pieces back together, right? Now with this, we can also use an offset. So if you aren't happy with how these pieces are breaking up, say perhaps this body chunk is too big over here, you can actually offset this. So offset to the left or right, or whichever direction you want, all right? So maybe a split like this is a bit better. Let's go ahead and enable our random detach. And again, you can decrease this detach amount, and maybe that looks good. So now we still have the issue of the inside faces having bad UVs. You can see that these UVs are really distorted, and that's not going to be great for when we want to enable our textures for the inside. Our textures are going to be as distorted as what we're seeing here. What we want are these nice little squares, just like we have on the exterior faces. You want these uniformly sized squares. That just means that your UVs have been projected well, and when we apply materials, then our materials and textures won't be distorted in any way. Of course, there are issues like this, where there's a seam, but if the actual material that you've created accounts for these seams, then you won't actually see them. So we don't have to worry about that because this cat model does have materials that have taken that into consideration. So let's just go ahead and do something about these inside faces. What we can use for this is a labs tool. We have the inside faces. So over here we have labs inside faces UVs. And what this does for us is it actually generates those inside UVs. And if you don't have access to this, just go ahead and download the labs tools. You can see over here that I have the labs tools over here. I believe you can just do it from the Houdini launcher over here. You can go over here to labs/packages, and you can see that I have labs installed. You can go ahead and install other packages. Now, before we plug it in, I actually want to put it before this RBD cluster. The way that this inside faces works is that it works best with simple geometry. So we actually want it before the RBD cluster where we start creating very complex collections of geometry. So we plug it in over here, right? Right after the material RBD fracture. And it's going to take a little while because we have to recalculate our cluster and things, but that should work. And then you'll see that we have these nice little squares. And so those look good, right? And the only thing that you might want to change is the scaling of those squares, because right now they don't really match the scaling of these outside. So what you can do is just use a UV transform. UV transform, plug that in after our RBD cluster, right over here. And we don't want to transform all of our UVs. We only want to transform the inside faces. So go ahead and choose the inside group, and then we're just going to scale it down. So it might seem weird scaling it down, but when we scale it down, these little squares will actually get larger. So as you can see, they get a bit bigger. We can do something like 0.3, right? So now we have these nice sized squares on the inside. So our UVs look good for the inside, right? And they're not going to be perfect, but they're going to be good enough. And that's all we need for these inside faces, just so that they aren't distorted. From there, we can use an RBD configure node. So this is where we set up things like our density and mass and the type of material that this should be. So go ahead and plug this in. And we haven't really used this node up until this point. We've used it, but I didn't really go over any of the settings, right? Inside of here, you'll see that we have things like concrete and the sort of physical attributes for it. This is going to become important when we come back to this and actually define how this cat should behave in our scene. And as we looked at in the previous parts, this actually packs our geometry up. This is one level of packing. The next thing that we want to do is an RBD pack node. So RBD pack, and this allows that second level of packing so that all of these pieces are considered one piece of geometry, just like this, right? So 3 packed geos, 1 for each input, and then we can transform this around. So go ahead and transform this up, just like this, and rotate it. Okay, now we can use an RBD unpack, and this can go into an RBD bullet solver. All right, bullet solver right over here. Go over to the collision tab and go ahead and add a ground plane right over there. If we play this back, you'll see that this cat kind of just falls and doesn't actually break or anything, right? Not exactly what we want, but this is what we end up with. And again, just enable your real-time toggle, but you'll see that it plays back quite slowly. The reason is because Houdini is doing some things behind the scenes. As we discussed, it actually does the simulation based on the proxy geometry. So if we view this output, this is actually outputting the render quality geometry. So if you want to speed this up, you can just take a null and plug in the proxy geometry over here so that you can play it back in real time, right? Just like that. So now the other thing that's happening over here is that this isn't really breaking up. And the reason for that is because of our glue constraints. So if you remember correctly from the previous parts, we looked at the constraints over here on our RBD material fracture. You can see that the primary strength is something like 10,000. As we saw, that's an extremely high value. The issue is that if we were to change this now, it would have to recalculate all of these things, right? It would redo these inside face UVs, our RBD cluster, our configure, our pack, our unpack, all of that would have to be redone. Now, that's okay in our situation. It'll be, maybe a 10-second wait. But if you're working with a large simulation, that may take several minutes. That may be a really slow process to get through. So this is where we want to start looking at the actual data flow in Houdini and start to get a bit more advanced. So we're going to look at the actual constraints over here. So let's go ahead and grab a null and plug these constraints over here from the RBD unpack into this null. As you can see, those are our constraints. If we look at the geometry spreadsheet, you won't see anything under the points. So you'll just have the cluster and the name attribute, but we want to see the strength of our glue. So we go over to the primitive attributes over here, and over here you can see strength. And the strength ranges from 89,000 to 2,000. So it's a pretty big range. Now, the thing is, if we wanted to make changes to that, we would have to usually go to the RBD material fracture and adjust the primary strength as we discussed. However, we can also adjust it from here. So I just want to show you something using an attribute wrangle. So go ahead and drop an AW attribute wrangle right over here. And inside of here, we can actually make adjustments to certain attributes. So over here, we have it run over points, but we have primitive attributes that we need to affect. So change this to primitives. Now, inside of here, we can actually change that strength attribute. The way we do that is we call at. At is going to be the syntax for looking at an attribute. So we say at, and then the name of the attribute, at strength, equals, and then we can make some changes to it. So if we set this to 1, and then use a semicolon, so a semicolon is like a full stop in vex, we're just saying make our strength equal to 1. And so if we now take a look at our geometry spreadsheet, you can see that our strength is set to 1 for every single constraint, right? So if we now take this and plug that in as our constraint geometry, let's take a look at what we have, right? So we play this back again. And so it's an extremely weak glue. And so now it just breaks apart, right? So we end up with that. Let's take a look over here. So that's clearly a bit too weak, right? We still have our clusters that are staying together, but we still want certain pieces to remain together, right? We don't want it to just break up into its clusters. So over here, instead of saying it's equal to 1, let's say it's equal to our strength. So add strength. And this is just going to make it equal to itself, right? So this won't change a single thing. But then we can multiply it by some amount. So we use an asterisk times 0.1. What that'll do is it'll multiply it by 0.1. So if we take a look at our geometry spreadsheet now, you can see that it now ranges in a different range. So over here, before we affect it, so over here we can see 89,000 down to 2,000. So if we're multiplying it by 0.1, then it should just be over here, as we can see, 8,000 down to 200. That'll probably still be too strong, so we can do 0.05 and take a look at what that looks like. So now you can see what we have, right? We're controlling these fractures in a much more interesting manner. We can now use this value over here to multiply our strength up or down. A better way to do this is to actually replace this times 0.05 with this function over here, chf, open brackets, inside of here, give it a name, and we'll just call it multiplier. That won't do anything, right? What we need to do is click over here where it says create spare parameters for all calls of ch, and that'll actually add the slide at the bottom with the same name as this over here. So now we can actually use this multiplier at the bottom to control our strength. If we go to our geometry spreadsheet, it's currently strength times 0, so it's 0. And as we slide this up, you can see that we now control it with a slider. So you can see something like that looks pretty good. We can now play this back again, and that looks decent. So the only thing that I'm going to do over here is decrease the size of our RBD clusters, because I think this is still a bit too big. So we'll do 0.1, something like that. Again, to our RBD bullet solver and play it back. All right, so that's okay. But we don't actually just want to be dropping it to the ground like that. Let's take a situation where we have something that collides with it. So I'm going to delete this transform node over here so that it comes back to rest position, right? If we play this back, it just kind of sits, nothing really happens. And that's exactly what we want as a starting point. Let's go ahead and add a collider. Now, the collider that I want to add is not actually a collider that you would add into fourth input as you usually would. That would be a static collider. Even in the case of a collider which is moving, I know it's a bit weird to call a collider that's moving a static collider, but when we say static collider, we're basically just saying that it's a collider that does not have two-way interaction. So the cat will be affected by the collider, but the collider won't be affected by the cat. And I can show you this. So if we had to add a sphere, I'm just going to add a sphere over here, view the cat, use a transform node to move the sphere and scale it down to 0.1. And then let's just go ahead and keyframe that position. Maybe we'll move it down a bit over here. So we're going to keyframe that position at frame 1, right over there. I'm going to skip ahead to frame 24. And we're just going to move it over to here, right? So all it's doing is it's moving like that. And if we take that and plug that into our collider, we can see what we end up with. So let's plug that in over there. And by default, it won't move. So if you want to be using this sort of collider, you're going to have to ensure that you change some settings. So over here where it says collision type, just set that to deforming and that'll fix it. So let's go over here and take a look at what we have. And the cat just gets knocked over. But that's not really what we want, right? The constraints aren't breaking and it just doesn't look all that good. So let's rework this. Let's remove this transform node over here and delete this connection over here, right? So let's try to do this the other way. Firstly, we want to set up our polygon mesh or our sphere as another set of fracture geometry. So to do that, we're just going to scale this down a bit. We're going to move it over to the side, just like that. And this time, we're not going to be focused on animating this. We're just going to add a force to it. So we can use the point velocity node. And there's a bunch of different ways you can do this. But basically what we want is we want our velocity to be traveling on the negative x axis. On this point velocity node, we can use add velocity and just set the velocity to -5 on x. And if you have your velocity trails enabled, you'll see this over here. So now we know that it's flying that way. What we can now do is just go ahead and add this to a group. So we'll add it to a group, and this group we can just call sphere. The reason that we have this over here is so that once we go ahead and start adding materials and things, we can differentiate between what's in the sphere group and what's in the cat group. That way we can easily distinguish between the two geometries, even though they're in the same simulation space. Okay, so now we want to replicate all of the things that we have going on the other side. So that'll be a material RBD fracture. Give that a moment to calculate, and then plug it into an exploded view just to see if it's working. So we'll just grab this one from the side over here. And if you don't see any fracture occurring, in our case, it might not be fracturing because our noise frequency for the scatter points is too low. So if you remember to earlier parts in this tutorial series, we discussed noise frequency. And when you see frequency, understand that higher frequency means more noise, right? So low frequency means big patches of the same values. In other words, very big noise patterns. And if we have very small geometry, then we want a higher frequency, not a lower frequency. So just push this up, and you'll see that it starts to fracture our geometry. We can also go over to the second level fracture and do the same thing. And there we go, right? So now our sphere is fractured. So now we can take this and use an RBD configure. So we're going to grab these three outputs and go into our RBD configure node, just like that, then into an RBD pack. And that is going to get merged with our other RBD pack, right? So we just plug this in over here. And let's go ahead to our output over here. And let's see what this looks like. And as you can see, the whole thing breaks, right? Right, so as we discussed before, the reason when this kind of thing occurs is usually because we have conflicting name attributes. So to fix this, we go to our RBD unpack and we say enforce unique name attributes per instance. Now we play this back and it works. But still not exactly how we'd like it to work. We don't really want this sphere to be breaking like this. We'd prefer if the cat were the thing that were breaking. So we need to make a few changes to what we have here. The first thing that we're going to do is on this RBD configure node, we're going to increase the density of the sphere. So we can just scroll down on our RBD configure to this area over here where it says physical attributes. And over here, we'll just do a user defined density and add a 0 onto the end of this. If we now play this back, you'll see that it now has a lot more weight to it, right? Now, our cat is having a bit of an issue, and that is that it's just falling over, right? We kind of want it to be pinned to the ground so that it doesn't fall over. So let's make a few changes. The first thing is that we want to increase our velocity on our point velocity to -7, so we have a bit more velocity to work with. So something like that. And then we want to just pin these bottom pieces to the ground. So how are we going to do that? Well, there's a very useful way to do it. If we take a look at our RBD solver, it actually has a bunch of attributes that get changed over time. It tells the solver what should be solved and what should be ignored, right? So you can see it has active, animated, and deforming. Now, the one that we're interested in is active. If a piece has an active value of 1, then the simulation will solve it, right? It will allow it to move about. But if it doesn't, so if it has an active value of 0, then it treats it as if it were static or frozen in place. So we can actually utilize that knowledge using an attribute wrangle. So attribute wrangle. And once again, our understanding of how simulations work are going to actually come into play right now, because we want to set that active attribute. But where do we want to set it? Well, it's going to be on the pieces that are being simulated. And the pieces that are being simulated are not first input. Those are the proxy geometries over here. So third input. Third input is going to be the one that holds that active attribute. So all we have to do is say at active equals 0. And I just want to prove this to you, that nothing will really do anything if we set at active to 0. You can see that everything just sits still. So we want to define it for only a few things. So we're going to use either an if statement or a group. I want to show you the group first. So if we go over here and just select a couple of points over here, so just click and drag and press enter, it'll only apply this to those particular points. But you'll have an issue if you play this back, right? You try playing it back and it still doesn't work. That's because this active attribute will default to 0 for anything where we haven't set it. So we actually need 2 attribute wrangles. One to set active to 1 for everything, so at active equals 1. So everything will now have an active attribute of 1. And then only these particular ones that have been set will have an active value of 0. Now, to just explain why this happens, let's just say we have a sphere over here and a cube over here, and we merge them together, right? So I'm just merging them together. And this one over on the right-hand side, right? If we take a look at this, we have no active attribute. But if I set a value on my box, so at active equals 1, right? What you'll see is that every point on the box gets an active attribute of 1. But when we merge it in, all the points that don't have a value for active default to 0. So as you can see, all of the sphere's points will be defaulted to 0. And that's exactly what's happening over here, right? When we set these points to have an active value of 0, anything that doesn't already have an active value is also set to 0. So everything gets set to 0. So what we need to do is first set everything to 1, and then only the few specific ones that we don't want active, we set to 0. Okay, so I hope that's clear. But once we have that, only the ones that are at the ground level should now stick to the ground. And that's exactly what happens, right? So the ones at the ground level are now stuck to their position. I just want to show you another way of doing this. It's probably easier if you understand code, but harder if you don't. So I'm just going to delete this attribute wrangle over here and remove this group over here. So what I'm going to do is I'm going to use an if statement. So I'm just going to make some space over here. Just say if, and then open brackets, and then open curly braces, and put this inside of my curly braces. So I'm just going to zoom in so you can see what I'm doing. I'm saying if, and then I have some condition inside of here. If this condition inside of here is true, then do this, right? So I'm going to say if v at p dot y, so the y component of my vector p is less than 0.05, make active equal to 0, else do something else. And I'm going to make active equal to 1. Now, this might look confusing, and I haven't really gone into vex in this series, but there's a reason for that. I wanted to show you that you don't need to know vex to actually work with Houdini in a very effective and useful way. This piece of code over here makes your life a lot easier, right? You can start to really work with Houdini to its full power if you understand vex. That's why I tend to teach vex, but I also want to show you that it's not entirely necessary. So we do have an entire series called Vex Isn't Scary. It's still more or less relevant, but we are working on a vex course. It's going to be a masterclass for our Patreon. And when that's released, I'll put up a little thing on YouTube just to say that it has been released. But the idea over here is that we're saying if this condition over here is met, then do this. Otherwise, do this, right? So if a particular point's y position is less than 0.05, set its active value to 0. Otherwise, set its active value to 1. Let's just see if that worked. And yeah, that works, right? So that works perfectly well. Okay, so that's looking pretty good. So now that we have that going, we want to now consider the opportunity to add some debris to this, right? You want to move on to the volumes part of this, because currently we have this nice little bit of destruction. All right, so we can go on to adding debris to our simulation. So what I'm going to do is just add a null over here. There's going to be our proxy out. We're going to just duplicate it over. And this one is just going to be our geo out, right? So this is just going to be our base simulation. Let's go up a level and hide this geometry node, because this is where we did most of our work. So now we can go ahead and drop a new geometry node. This one we can call render geo. Dive inside of here, and let's use an object merge node. So we're going to use this object merge, and all we're going to do is grab the geo out, right? So this is our high res geometry. That's what we have over there. And then we're going to add another geo node over here. This one is going to be called debris simulation, right? So I'm just going to move it down here. We're going to dive inside. Inside of here, once again, we're going to use an object merge. Now, an object merge node is just useful for bringing in things from another object. So we can go ahead and grab our proxy out, and all that's going to do is just bring in our nice proxy geometry over here. You'll see that it's still playing back slowly, and that's because if you look carefully, it is actually still templating our high-res geometry. What's happening here is that we're ghosting it in the top right, so we can just hide other objects, and now it'll play back smoothly. So this is just that proxy geo that we're fetching from over here, right? So this node over here is what we're fetching in our debris simulation. We're then going to use a debris source node, debris source. And when we place this down and plug this into the first input, you would expect it to work, but nothing happens. That's because the debris source node actually doesn't work with individual points. What it needs is unpacked geometry. So we just say unpack, we unpack this over here, and then our debris source will work as it should. Now, what is this doing? Well, based on a few parameters, it's finding the points that are separating. So where we have an impact, points will separate away from each other, and that's how it knows that there has been a fracture. And then, based on velocity, it adds some points. So what we can do is increase the density scale. We want a lot more points over here. So this is going to be 10,000 or even 50,000, something like that. You can go way higher with that if you want, but for now, we'll just keep it at that. We'll go all the way down to the bottom, and we'll say remove unreleased. So what that'll do is only the points that are being released are the ones that are going to be shown, right? Everything else is going to be deleted. Now, we also want a speed threshold, because if we take a look at this, those purple ones over there, they shouldn't really stick around. They shouldn't be emitting more points, right? Those shouldn't be emitters, because what we're going to do is all of these points that you're seeing over here, they're going to be put into a volume rasterized node, and that's going to emit smoke. So I'm sure that you can imagine most of the smoke would occur on impact, so around here, but then most of it would fade out around here. So that's exactly what we want. So just change the speed threshold until these start to disappear, right? So just push it up. So now that should work, but there's actually an issue. The issue is that our sphere that we have created actually maintains its velocity. So remember the velocity that we added to it for the initial simulation? Well, that stays on it, and we don't really want that. So all we have to do over here on our unpack node is actually transfer V over from the simulation. What that will do for us is if we now take a look at our trails, all the velocities look correct, right? So let's just remove that. You can see that they look all weird. As soon as we use the velocity from the simulation, it all looks right. So ensure that you're transferring the velocity attribute from your unpack node. Now we go back to the debris source, let this run again, and all we end up with is that one little point. So let's decrease our speed threshold. There we go. So now it's starting to look good. So now we actually want these to trail some points behind. So what we're going to use for that is a pop network. So just a pop net over here. And this pop net, we're just going to dive inside and we're going to make a few adjustments. So we want it to have a source of all points. If we play this back, you'll see that we now have that, right? And that looks like a bit of a mess. So there's a few things that we need to change. So first thing that we want to do is add some gravity. So let's go ahead and use a gravity force node, place this at the bottom over here, and then we should have something that looks a lot better. All right, so that's not bad. The issue with this is that we don't have a ground plane. So let's go ahead and add a ground plane and then use a merge node. And you can put it either after the gravity or before, it doesn't really matter. Plug the ground plane in and then either switch this to a mutual relationship or just swap the inputs around so that the ground plane is on the left because the left input affects right input. Then we can go ahead and play this back. And now it's starting to look a lot better. Now you will see that these are surviving for quite a long time. And maybe you don't want that. So on the debris source over here, we can actually change the lifespan. So over here where we have lifespan, we can decrease this to something like 0.25. And that will actually affect how long they survive inside of our popnet. Because if we take a look at the debris source, it actually has a life attribute that it feeds into this popnet. And so in the popnet, instead of using this life expectancy over here, it actually just fetches it from the attribute that's being brought in. So if we go over to simulation and reset our simulation and then play this back, you'll have something that looks a lot better. Now, the one thing that you might want to adjust is the amount of velocity that's being fed into the simulation. If we go into our popnet and take a look over here and our attributes, you can see that it's using the inherited velocity. What I like to do is actually add to the inherited velocity. So I'll drop this to like 0.75 and then add a bit of variance. What that'll do is do something like that, where it's less uniform. Before, it was all following the same sort of velocity, but now it's more like a cloud. And this is, of course, going to change depending on what you need. So perhaps for this situation, we want lower variance and lower inherited velocity. something like this. And that looks a lot better to my eye. Okay, so now that we have these particles, what we want to do is just delete the attributes that exist on it. There's a bunch of attributes that we don't need. If we take a look at this, we have all of those over there. So we can use a delete attributes. Attribute delete right over here. So we're going to delete everything except V. So just type V over here and then say delete non-selected. So that removes everything except our V attribute. The next thing that we want to do is just add a density attribute. You can use an attribute create or you can use an attribute wrangle. I'm going to use an attribute create over here. So attribute create, the name will be density, and the value down at the bottom will just be 1. Alternatively, if you were to use an attribute wrangle, you would just do this where you say at density equals 1, semicolon, and that does the same thing. So we can use this one instead. Then you can use a rasterize attribute, so volume rasterize attributes. And over here, we're just going to go ahead and grab our density, and we're going to grab V, and we're going to set our visible volume to just be density. And remember, we don't have a p-scale, so it's all just going to be this massive uniform size. So we're going to scale this down to 0.01 for particle scale, and then decrease the voxel size to 0.02. Right, so now we have a decently high resolution volume. So all of those points from our simulation, they are now turned to a volume. The one thing that I do want you to be aware of is if you take a look at this popnet and then take a look at all the points, you'll see that there are some lingering points from the ground plane. That's because this popnet outputs everything. If you want to output just this simulation, then what you have to do is go over to the object over here, remove the asterisk, and over here, just use the pop object, right? So we don't want the ground plane as well. So if we do ground plane and pop object, it'll be that. We just want the pop object. Cool. Now we have that over there. Now for our final simulation, we're going to use a Pyro solver, and we're just going to plug this into our Pyro solver. Once again, on this Pyro solver node, we're going to want to adjust our voxel size to 0.02. And then under bounds, we're just going to go to bound conditions, treat Y as closed below 0. That's just going to act as a ground plane for us. And if we play this back, I'm just going to press D, set the background to dark, right? Something like this. So let's see what we have. Okay, so we have some debris. Now, the thing about this smoke is that it's firstly quite uniform, and secondly, it lasts for a bit too long. So let's go ahead and actually make some changes to this. Under dissipation, we can increase it to 0.5. Then we can go over to the shape and add a bit of disturbance. So just 0.2 on disturbance. Play this back. And it will already start to look a little bit more natural. Now, of course, this is up to you, depending on how you feel this should look. You can take a look at some reference images if you want to get a better feel for how this should be. But playing around with these settings will get you some decent results. So I'm going to increase the disturbance over here. And I prefer that. Maybe decrease the dissipation a bit. And there we have it. So you can play around with these settings until you find something that you're happy with, but I'm just going to use these so that we can move along with this tutorial. So I'm going to go ahead and drop a null over here. And this is going to be our debris out. Jump up a level, hide the debris simulation. Once again, drop a new geo node. This one over here is going to be render debris. Dive inside of this, object merge, go ahead and grab that debris. So from the debris simulation, we're grabbing the debris out, and we just have that over there. So if we go over to the stage level, let's just go ahead and use a SOP import node over here. This one we're going to rename to RBD. We're going to go ahead and grab our render geo over there. So that just brings this in for us over here. We're then going to add a grid. So that's just going to be our ground plane. So plug that in over there and just call this ground, and then use another SOP import over here. And this one over here, we're just going to call debris. And then we can go ahead and grab our debris. So render debris. That brings everything into our simulation, and we can just press D and then background, set this to dark to just hide everything else, right? So now we can go ahead and start looking at setting up some materials. Let's switch this to our Solaris desktop so that we have access to our scene graph tree. Inside of here, you can see we have RBD, but it's still broken up into all of these clusters and things, and that's not really what we want. So what do we want? Well, let's go ahead and take a look at our render geo. So what we have coming into our render geo over here is still packed geometry. We can go ahead and unpack this, and now we have this over here. Once again, transferring the V attribute so that our velocities are all as they should be. And now there's a couple of things that we have access to. We have these primitive attributes called cluster and name. We have these prim groups over here. We also have this inside, outside, and sphere. So let's make use of all of these things. Firstly, let's use an attribute delete node because we don't need all of them. The things that we don't need are these over here, cluster and name. Right now, we don't actually need them, so we can remove them, right? So asterisk on all primitive attributes, that'll just remove them. And now we just have these prim groups over here to work with. We can go back to our stage level over here. And if we expand our RBD, you'll see that we just have a single mesh. Again, that's not what we want. So on this RBD over here, so the SARP import node for RBD, go over to the import data over here, and let's scroll down to subset groups. Over here, we just want to add inside, outside, and sphere. Now, if we take a look at our mesh, we have inside, outside, and sphere. They're all separated into different groups. These groups are going to be useful for applying materials. So now we can go ahead and use a material library, plug this in at the bottom. This material library, we can dive inside, and we're going to be using material X. So we can use a USD subnet, so USD material X subnet, and this is going to be our inside. We're going to start with the inside group because it's going to be the same for everything. So dive inside of here, and we're not going to be using displacement for this one, so we can delete that, and also delete these two over here. We just need this surface output. Go ahead and use an MTLX standard surface. Plug that in over here. And now we're going to use some MTLX image nodes. So this one over here is going to be for our diffuse. So go ahead and inside of our assets, we're going to use that rough concrete. So inside of here, we're going to grab the diffuse, plug that into the base color. Make sure that the signature is set to color, and then we can do the same for roughness, right? Let's go over here and choose roughness. This one is going to be a float because roughness is a black and white image. So we can grab the roughness and put this into specular roughness. We're just going to use those two for now. So we can go up to the stage level, and right over here, we'll just say autofill materials. It'll add this inside material, and the geometry that we want to assign it to is this inside group. So we can click and drag this over right over here. So as you can see, the inside group for everything has now been assigned a material. And if we take a look at this as a comma render view, you can see that it has this material applied. Okay, so you will notice some issues, such as there being no UVs on the inside of these pieces over here, and there's also not much detail on them. And that's something that's very easy to fix inside of your RBD destruction. Over here, you can add more complexity to your sphere. So you can go ahead and add things like edge detail, but the only thing that I'm interested in is adding UVs to the inside of this. So we're going to use the inside faces, so lab inside faces. Once again, just plug it into the first one over here, right? So let's take a look at what that looks like. We have those over there. Remember, we used a UV transform node, so we can also copy that over from the left side and just plug this in over here. So now we have inside UVs that are being transformed down so that they're a bit bigger. Okay, if we now go back up to that level, we're going to have to recalculate our simulation. But going to the stage level, you'll now see that we have detail on the inside faces of these chunks as well. Again, you can go ahead and add more detail to that if you'd like, but that's going to do for our purposes at the moment. Okay, let's go ahead and also make a material for the floor. So USD subnet, once again, we can call this one ground, dive inside, delete everything here except the surface output. Go ahead and use a MTLX standard surface, plug this in here, and then give this a bit of a base color. I'm just going to make it something like black, and then I'm going to reduce the specularity of it. So increase the roughness and decrease the overall specularity. Okay, so upper level, autofill materials, assign this to /ground, and we're starting to get somewhere. Let's also just set up a camera. So let's find an interesting spot. So something like this, and set up a camera. We can also drop a comma render node, switch this to comma XPU, and that's what it looks like so far. Okay, so that's working. We're going to just finish up our materials, and then we can get around to actually setting up some lights. Let's go ahead and use a material X subnet once again. This is going to be cat underscore outside. And inside of here, we're going to have to do some setup once again. Standard surface, MTLX image. This one is going to be our base color, so go to the textures for the cat. Diffuse color over there, straight into base color. We can duplicate this one for roughness. Then we can go upper level, autofill materials. Over here, we'll just grab the path for the outside. So click and drag it over. It will apply it to our sphere as well, but we'll get around to fixing that. If we now render it, we now just have that over there. Now, do keep in mind, we don't actually have normals on this cat. And there's a reason why I haven't shown you how to put normals on yet. So do keep in mind that Material X is still under development. And one of the issues that I found with normals is that it doesn't work correctly if you use it inside of a Material X subnet like this. So what we can actually do is just take this. So we're going to take everything that's in this cat outside subnet and cut it, and then just paste it over here, right? So we're going to paste it up here, and we can delete this cat outside node, And the issue seems to arise with using the MTLX image node with an MTLX normal node. So what we're going to do is use the USD texture node, right? So this one, USD UV texture, works basically the same. All we have to do is go ahead and find our cat normals. So over there, all we have to do is plug this into an MTLX normal map node. So over here, MTLX normal map. So RGB goes into the in input, and then that goes into your normals. Now let's just rename this MTLX standard surface to cat underscore outside, and also switch on its render display flag. So switching on the render display flag over there will now re-enable it over there. If you aren't seeing it, then go ahead and delete the cat outside node, autofill the materials, and just drag it back over. So just reassigning it. Let's take a look at that. And that seems to be working, right? We have normals on the surface of our cat. So now we can consider doing something with lighting. Let's start with an edge light. So we'll just go behind over here and just choose an area light. So we'll place one behind it like that. Looking at it from the front, so from our camera view, you can see that we're just getting that edge lighting over there. We can make some adjustments to it until we're happy with it. So perhaps move it around to that side, move it up a bit, move it back a bit. And another thing that we can do is we can also go over to the shaping tab and switch on spotlight, and then we can reduce the angle, right? So we can close it in a bit, just like that. And then once again, increase the exposure, right? So we just have something like that. Okay, so I'm just going to switch my background to dark. That's providing some pretty good harsh shadows and harsh lighting, but we need to tone down the shadows over here. So let's use a full light on this side. So the idea is to just keep playing around with this until you find some sort of lighting that you're happy with. And then you can go ahead and start playing with the colors of each of these lights. You can also use a light mixer. So a light mixer is a really cool thing that you can use once you've already set up your lights. So you just plug all of your lights into the light mixer, and then you click them over here. Shift and click on each one and drag them over to the right. And from here, you can actually adjust all of their different colors from here. So if you want to adjust one of the colors, and let's just reorganize this so that our lights are all in the right place. Now, there's only a few minor things that we're going to need to change. Let's go ahead and add a material for our smoke. So inside of here, we're just going to use an XPU Pyro preview node. And this is just going to be our debris. Over here, we can once again autofill the materials, and let's assign this material debris to debris. Just like that. Let's skip ahead a bit. And that's what we have. So of course, we'd want to make some changes to that. The smoke color should be closer to the color of the actual geometry. So something like that. You can increase the shadow density and decrease this density over here, or increase it, right? So you can play around with these settings. Perhaps you want it as a darker smoke, something like that. And let's push up the scattering phase a bit. Okay, so that's the sort of thing that we have now. The last thing that we might want to add is a motion blur. So let's just go onto our camera render settings, go over to camera effects, and over here under velocity blur, just set this to velocity blur. Thankfully, everything that we have, all of our simulations, all have velocity on them. Otherwise, you can use the motion blur node. There's a bunch of other options that you have for this. And once you have that, you'll have a decent looking render, right? So it's quite a bit of smoke and stuff, but you can play around with the settings until you find something that you're happy with. So as for the sphere, what exactly is the issue, right? Why is it difficult to separately assign materials? Well, that's because everything is being brought in as a single mesh, right? We have inside, outside, and sphere. So what is a better way to do this? Because there's some overlap here. Sphere also has an inside and outside group, but when we apply to outside, it applies to both of them. And when we apply to inside, it applies to both of them. So we could actually separate this out. If we go back up to our render geo over here, let's go ahead and use a split node. So we're going to use a split node right over here. And in the split node, we're just going to choose our sphere. As you can see, it then splits it. So if we invert the selection, we have the sphere over there or the cat over there. It gives us two outputs. So what we can do is we can output one on the side here, which is just our sphere out. That's that over there. And on the other one, we can output cat out. right? So now we have two geometries that we've split up. Now when we go over to our stage network, instead of just importing it over here as a single RBD, we can actually import both, right? So I'm going to delete that SOP import and just do one over here, SOP import, and call this sphere RBD. Then we're going to go to our SOP path, and from here we're going to choose the sphere out from our render geo. Accept that. Once again, we're going to need to import the groups. So import data, subset groups, inside, outside. And just to keep it simple, I'm going to duplicate this node, Alt, click, and drag. Rename this one to cat_RBD. And the only thing that we need to change is what we're bringing in. In the SOP path over here, just choose the cat. And now we have the sphere and the cat, and we plug that in. And then from here, we can make changes to them individually. So I'm just going to clear all of our assignments over here, autofill materials, and we can just reapply all of our materials. So we have inside over here as a material, and there's a bunch of ways that you can apply it to the inside of the cat mesh and the inside of the sphere mesh. I'm going to show you a pretty cool way. So I'm just going to bring in one of these inside groups over here. So you can see that we have sphere RBD mesh 0 inside. But this over here, right? This over here, what happens if we just make that a wildcard and then say anything? So we say / asterisk / mesh 0 / inside. What that'll do is it'll look inside of everything. And if there's a mesh 0 with an inside group, it'll assign this. So everything will get that assigned to it, right? All of the inside groups. Then we also have the ground, so we can just assign the ground. Then we have the cat outside, so just drag that over. Then we have the debris, drag that over. And the only thing that's left is the outside of our sphere, right? So we've separated everything out. And now it's really simple, right? Now you can just apply something to the outside of that sphere. So let's just do that quickly. If we duplicate the ground over and call this sphere outside, dive inside of here, give this a base color of something like a blue, go back up, autofill, and then just drag over the outside group, right? Just like that. So the inside of the sphere will still be that concrete material, as we can see over here, but the outside will be that blue material. Let's go ahead and see how this looks. And there we have it. So now you know how to do destruction mixed with Pyro, right? We can now combine RBD and Pyro to end up with interesting results. We can now work with debris, and from this you can also stem understandings of explosions and things like that. Because really, it's always the same systems in just more advanced setups, right? You just expand on those same understandings further and further and further for more complex setups. And of course, there are going to be some small things that are very specific to your project. But for the most part, this is kind of how you would go about doing a bigger project as well, right? You would break it up into all of its constituent parts. And just like this, you end up with a final product. What I would recommend is cleaning up your networks a bit, just so that they're easier to understand. So for example, you can grab all of the lights over here, and what you could do is you could separate them out like this, and then use a merge node, right? So merge in all of your lights. Then you can also do something like putting them into network boxes. So grabbing all of those, put them into a network box, right? Put your geometry into a network box. All of those sorts of things really help you as you start to create more complex projects. But I hope you start to understand how Houdini works now. How you'd have two sort of simulation networks over here, then you'd have two for rendering, and then at the stage level, you would bring in the geometry and you would separate it in whatever way you need, and then you would just light it, you know, separately on the side over there, merge it all together, render it out. So that's all for this part. I do hope you enjoyed it. This was a bit of a different format, so I hope it didn't bother anyone too much. Hopefully we'll be back to our usual style very soon. We are just moving premises at the moment, and we're looking for a new place to set up our videos. And as soon as we're happy with that, we'll go back to recording in the studio. So that's all for this tutorial. Thanks for watching. Bye.